It's very nice to be here today. As I was very kindly introduced, my name is Matthew Brooke. I am the Programme Manager for Reporting of Animal Research at the NC3Rs. As I say, it's a pleasure to be here today. I've very much enjoyed hearing the talks so far. I am here to give you an introduction to and an overview of the ARRIVE guidelines, as well as lead you through a couple of little activities that we have that might help us to understand the benefits of reporting animal research better. So before I started, I'm not sure how many of you are familiar with the NC3Rs, so I thought I would just give you a brief introduction to our organisation. So the NC3Rs is the National Centre for the Replacement, Refinement and Reduction of Animals in Research. We are an independent scientific organisation. We're based in the UK. I'm coming to you today from cold and cloudy London. We are focused on the discovery and application of new technologies and approaches to replace, reduce and refine the use of animals in research. We collaborate with scientists and organisations from across the life sciences sector, both nationally and internationally. That includes universities, the pharmaceutical industry, chemical and consumer products industries, other research funders, regulatory authorities, and many others, including other scientific organisations. We are primarily funded by the UK government. Most of our funding goes into funding of 3Rs research, but we also have a wide variety of in-house programs led by the scientists that work in the NC3Rs office, including myself. This includes the Experimental Design and Reporting Programme, of which I make up part, which focuses on providing resources and advice on good experimental design of animal research and good reporting, as I mentioned. You can find out lots more about what we do, the resources we provide, the funding that we have provided and will provide in the future, all via our website, which is nc3rs.org.uk. So I thought I would give you a little outline of what we're going to be doing over the course of this next 45 minutes or so. So this will be a little mixture of listening to me talk, and then we'll have a little bit of an interactive session, which hopefully people will enjoy taking part in. So I will be, first of all, giving you an introduction to the ARRIVE guidelines, talk about why they were developed, what their purpose is, and the kind of the help that we hope they can give to animal researchers. Then I'll talk about a couple of the ARRIVE guidelines items in a bit more detail, just so we can understand their importance. Then we have a little interactive session, which is based on an online whiteboard tool called Miro, which I'll provide the link for in a few minutes, that people can log into, and through that we can have a look at finding out kind of how easy or difficult it is to find the information you need in research to understand and replicate a study. Then once we finish that, we will come back here and I'll talk a little bit more about how we can use the tools, ARRIVE-based tools and NC3Rs tools, to report your animal research a bit better. So the ARRIVE guidelines. ARRIVE is an acronym which stands for Animal Research Reporting of In Vivo Experiments. The guidelines are a tool that we designed to improve the reporting of biomedical research that involves animals. The guidelines consist of a checklist of individual pieces of information, which we call guideline items, that should be included in any animal research manuscript to ensure that it's reported transparently and accurately. The original guidelines were first published in 2010, so 11 years ago now. However, over the last kind of 3 to 4 years, they were comprehensively revised and updated. The revised guidelines were then released last year in July. We call these revised guidelines ARRIVE 2.0, and they show quite a few kind of differences from the original ARRIVE guidelines. So what do the guidelines cover? There are 21 guidelines in total, and they cover a variety of different types of information that should be included in a manuscript. There are items that cover internal validity. So these are things that are important for understanding how reliable a study is. This includes things like describing the study design, describing how animals were allocated into groups, and how the sample size was chosen. After that, we have items that are important for reproducibility. For example, a comprehensive description of experimental procedures, description of your animals, their characteristics and their source and so on. And other items provide information about the context and the scientific relevance of a study. For example, Arrive requests details of the scientific background of the study, the relevance to other species, and details of ethical approval. The guidelines apply to all in vivo research. So it doesn't matter whether you're using a mammalian species, fish, amphibians, invertebrates, or anything else. It doesn't matter whether the species that you're using requires ethical approval, or for example, it's a juvenile of a species and therefore doesn't require approval for that reason. The guidelines are designed to be about rigorous science and open science, which of course fits in with the topic of today, and therefore they can apply to any animal experiment. So to understand the reasons why we developed the Arrive guidelines, we need to have a little examination of reproducibility in preclinical research. Scientific publications that report animal research very often lack important information, and that really does limit how useful they are. It's important for research to be reported transparently and accurately if research can be reproduced. I'm going to show you an example now, which is something called the Reproducibility Project in Cancer Biology. This was a project that began in 2013. It set out to reproduce the findings of 50 high-impact cancer biology papers that have been published over the preceding decade. Since that time, it's reported the results for 16 of these papers, 16 out of 50, with mixed results. Some of these findings could be reproduced, some could not be. But what is very interesting from our perspective today is the way in which the number of papers that the project were focused on was forced to reduce its scope. So the project began aiming to reproduce 50 papers, and this was gradually reduced over the years through 37, 29, 18, and finally down to 18 papers from the original 50. The reasons behind this reduction were firstly that materials were not available to reproduce the study, which can be understandable. But secondly, the papers themselves didn't provide enough methodological detail to be able to reproduce these papers. And that is to say, even this very highly consequential research published in high impact journals with a lot of citations can't be reproduced if it's not transparently reported. And this was a major factor that drove the development of the original Arrive guidelines. So since 2010, when the original Arrive guidelines were published, the guidelines have received good support from the scientific community. They've been endorsed by over 1,000 different stakeholders, including journals, funders, universities, and learned societies. The NC3Rs has in the past produced hard copies of the guidelines, pocket-sized versions, hard copies of the guidelines, and over 40,000 copies of these have been requested from 50 different countries around the world. I should say we are going to be producing pocket-sized versions of Arrive 2.0, and we've had quite a few requests for those so far. However, you can possibly tell I'm currently sat at home. We're not able to kind of use our office at present to its full capacity, so we're not able to send out these physical hard copies of the guidelines. However, we'll hopefully be doing that quite soon, and if you're interested in receiving them, please do let me know and we can send you as many as you like free of charge. So please get in touch if needs be. So despite the fact that we've had this high level of endorsement of the guidelines from various different bodies, it was important to us to examine whether or not the guidelines were actually having their desired effect. Were they affecting the quality of reporting in scientific publications? So to do this, we can look at how indicators of good reporting appear in scientific publications over time. So this data doesn't come from an NC3R study, it comes from an independent study that was published just at the end of last year, 2020. In this study, researchers used a tool called SciScore, which is an automated software, to analyze 1.6 million open access research papers on PubMed Central. This first graph on the left is looking at a subset of those papers, those reporting animal research, of which there were over 51,000. And it looked at the proportion of those papers that reported these measures of subjective bias in them. So specifically, it looked at papers that mentioned the sex of the animals, randomization, blinding, and a power calculation for looking at sample size. And as you can see, the percentage of papers mentioning the use of these measures is really very low. So randomization was only mentioned in 37% of publications, blinding in only 12%, and a power calculation in only 7% of these publications. Next, this graph on the right shows how these measures have changed over time. So this is looking at all 1.6 million papers. This is both preclinical papers and clinical studies, showing the change in some of these indicators over time. So you can see, for example, this the yellow line shows that papers mentioning randomization from back before the year 2000 up to close to the present day. So you can see there has been a substantial improvement in papers mentioning these criteria in some senses, but yeah, overall the degree of papers that mention these criteria are still very low, and therefore for that reason the NC3L set about the process of revising the ARRIVE guidelines in the hope that we could make them more effective in achieving their goal. So as part of the first part of this, we conducted a survey, an international survey of in vivo researchers, and we drew a couple of conclusions from this. The first of this is that knowledge of the ARRIVE guidelines is associated with more rigorous study design. This confirmed a previous 2016 study which showed that knowledge of ARRIVE is associated with good practice in experimental conduct, evidenced by reporting the use of measures of subjective bias, like I mentioned, randomization, blinding, sample size calculation, and so on and so forth, among other things. The second thing the survey found was that poor quality reporting is mostly reflective of the perceptions and attitudes of the scientific community towards reporting. What this means is things like researchers not understanding the requirements to report some things, or believing that they don't need to report them in some study types. And this is rather than any requirements that journals might or might not set out for reporting. So following this, the NC3L convened an international working group to revise ARRIVE. This had 28 authors, including representatives from funders, journals. We had statisticians, methodologists, and researchers from a variety of backgrounds. As part of the process, we undertook a Delphi exercise involving 73 participants from 19 countries. And following the publication of an ARRIVE preprint on bioRxiv, the revised guidelines, and the E&E, which is the explanation and elaboration document that we published alongside ARRIVE, these were road tested by researchers who were preparing manuscripts describing animal studies to ensure that the documents were well understood, that they were useful to their intended users. So the results of this was the publication of the revised ARRIVE guidelines, ARRIVE 2.0, which contain 21 items, some of which have sub-items within them. These differ from the original guidelines in a number of ways. So the items have been updated, a couple of new ones have been added, some have been split, some have been merged. But really the major change from the original ARRIVE guidelines is that the guidelines have been reorganized into these two sets. They've been prioritized. This allows for initial focus by researchers, journals, and other stakeholders on the most crucial items. So these most crucial items are the ones we've put that have been put into the ARRIVE Essential 10, which is the left-hand table you can see here. These items are the basic minimum that should be included in an animal research manuscript, because without this information, reviewers and readers can't confidently assess the reliability of the findings. These include things like, I'm not going to just read the whole thing out, but things like describing your sample size, how that was calculated, randomization and blinding, describing your experimental animals and procedures. Then alongside this, we have the right-hand table, the recommended set. These are 11 items that complement the Essential 10. They add important context to the study. They include details such as things like the ethical statement, background, objectives of the study, protocol registration, data access, and other things that we've heard about today. We should emphasize, however, that reporting all of the items in both of these sets represents best practice by researchers. So in addition to the reorganization of the guidelines, we also published, as I mentioned before, the explanation and elaboration document, which is quite an extensive set of information providing the reasoning behind the inclusion of individual items, examples of good reporting from the published literature, and so on. And this, it helps to hopefully address the issues around researchers not understanding some of the reporting requirements or believing them to be unnecessary, for example. Now, the guidelines can be used throughout the course of a scientific study. As I mentioned, we published this extensive explanation and elaboration document, which that contains quite a lot of useful information on experimental design, in addition to explaining the individual ARRIVE guideline items. What that means is that consulting the guidelines during study planning can be very useful to help you design a rigorous and reliable in vivo experiment before you even start. The guidelines are also useful during the study, so to help researchers to record the information they'll need when reporting. They're useful, of course, when writing the study to make sure that all the important information is included, and can be very useful when reviewing a study to ensure that the information is available to evaluate that research. So I just wanted to spend a few minutes talking about a couple of the items in a bit more detail to understand why they were considered important to include. So firstly, I want to talk about randomization. The guidelines insist on including details of whether randomization took place and the method that was used to randomize the, for example, animals into treatment groups. The method by which randomization took place was important, particularly when, as I say, allocating animals to treatment groups. An approach that's haphazard, which describes something, for example, just picking up, for example, if you're using mice, picking up animals from the cage in the order that you happen to be able to reach them, is not a random method. And you need to really use a validated procedure to randomize animals into groups. This can be, for example, using a computer-generated list of numbers, throwing a dice, flipping a coin, just really something that you're not able to subconsciously influence. The randomization has two main purposes in studies. First of all, it helps to minimize selection bias and reduce systematic differences in animal characterization. So, for example, in the example I just gave you, where you have a cage of mice and you're just picking them up in what seems like a random fashion, but you're just picking up the ones that you can reach in the first place, the results of that might be that you're just putting all of the slowest mice into the same group because that's the easiest way to catch them. Secondly, randomization helps to meet one of the key assumptions of statistical analysis, which says that different groups should be drawn from the same background population using random sampling. So if you haven't properly randomized animals into groups, then statistical analyses on them cannot really be considered to be valid. I'll just demonstrate the difference here between haphazard and random selection, if I can. So this graph on the right here shows the results from a simple internet poll published in a blog called Cognitive Daily a few years ago now. The poll just asked users to pick a number between 1 and 20. So, and then these results were compared to a truly random allocation derived using a computer. So there are 20 numbers available. So if it was truly random, each number has a 5% chance of being picked. And that's essentially what the computer results show. The computer results are these white bars here, and they cluster really around this 5% line, with of course some variation between them. However, when humans are asked to pick a random number between 1 and 20, there's a real peaks at both 17, over nearly 20% of people pick 17, and over 10% of people pick number 7. There may well perhaps be some cultural reason for these results, but the real point that should be made here is that human beings can't do random. Humans can't just randomly pick something in a truly random fashion, and therefore if something is going to be randomized, it needs to be done using a validated method that you can't influence with your own judgment. Secondly, I'd like to quickly talk about the importance of blinding. So the ARRIVE guidelines recommend describing who was aware of group allocation at different stages of the experiment. that is, who was blinded to different steps in the experimental process. To demonstrate this, I'd like to quickly talk about another study that was published. This is way back in the 60s now. This experiment was carried out by 12 studies on mice and on rats, apologies. It involved two populations of rats. One population was called maize bright rats. These had been bred over many generations to perform well in maize tests. And a second population of maize dull rats, which again had been bred over generations to do poorly in these types of tests. These rats were put into an elevated T maze, quite a common psychological test, and received a reward when the rats went down the dark arm of the T maze to reinforce that that was the choice that they should do. The experiment was carried out over 5 days, and the 12 students counted the number of correct turns that the rats made towards the dark arm. Here are the results of that experiment. As you can see on the graph, the maize bright rats did significantly better, as you might have expected. The bright rats started off better and improved further over the 5 days of the experiment. However, what was really interesting about the study is that it was actually being performed on the students and not the rats. There was, in fact, no difference between the two populations of rats. They'd been labelled bright or dull completely randomly on the morning of the experiment. And the only difference between the two populations was in the minds and the expectations of the students who ran the experiment. The students found the rats in the bright group to be brighter, cleaner, tamer, more pleasant to work with compared to the dull group. And the students described their experience of working with the bright rats to be more relaxing and casual. So the differences in this graph that were found in an actual experiment were entirely down to the differences in the investigators' behaviour and their preconceptions of how the rats would behave, rather than what actually happened. So this really highlights that blinding is extremely important, because researchers really do have the capacity to influence the results of experiments when they're not blinded to quite a high degree. So,
Matthew, there's
yes.
a question in the chat.
Oh, sorry, I can't see that.
No, so do you want to answer them now or after you finish?
Yeah, now is good for me.
Yeah, so there is a question about the sources of randomizing that are accepted by the guidelines by Martin Taylor. He's asking this. Can you?
So what I would say, rather than me going through kind of a list of kind of acceptable things now, what we have on the Arrive website, I believe I've mentioned a couple of times this explanation and elaboration document. So all of the information from that is on the Arrive website. I'll show that to you a little bit later, just kind of show you how that's laid out and how you can find it. So the explanation and elaboration for the randomization item gives you quite a lot of kind of guidance on what's considered a validated method for randomization, how you can do that. So it's a good kind of long detailed explanation of that, which I'll show you that a little bit later on, and that has a lot more explanation than I could just kind of give you offhand now.
Yeah, I saw a thumbs up, so I think he's happy with your answer.
Brilliant. Yeah. Sorry, I can't actually see the chat the way I'm set up at the moment, so apologies if I'm missing the questions.
Yeah, no, that's why I keep track of it. Yeah.
Okay, so next we are now going to try to do a little activity, an online activity. So for this we're going to use something called a Miro board, which is an online collaborative whiteboard. So you can either take part in this if you'd like. I'm just going to put the link to the Miro board in the chat if I can. I'm not sure where the chat's gone, sorry. There it is. The chat. You should all be able to navigate to that. You'll need a password to open it up, which is right here. It's Arrive 2021. If you don't want to take part in the workshop exercise, you can kind of follow along through my screen, and I will show you what we're doing here. So I'll just give everyone a minute or two, anyone that wants to take part, of course, to join the whiteboard, and I'll talk a little bit about what we're going to do. So I am aware of the time, so I will try and keep this section as short as we possibly can. So this is a Miro board. What we have here is something that's quite simple to use. I'll show you how to use it in just a second. The key thing that you'll be able to see, you will each have a little bar down the left here, which has a number of little tools you can use. The most important thing, if you just click this top mouse cursor button so that it goes blue, you will be able to use the you'll be able to manipulate things on the board. Apologies, the password is, I will put the password in the chat too. So the useful thing about this is if you're not following along, if you're actually in the Miro board, what I can do is bring all of you to me. So I can really determine whereabouts you are on the board, and we can all look at the same things together at the same time. So for this little exercise, what we like to do is to understand how experiments in the published literature were carried out. And we're going to have a look at whether or not we can find the information in a couple of example papers quickly and easily. So what we're going to do is look at, I've got 2 published studies on here, but I think for the purposes of time, we might just look at one to see whether or not we can figure out what the sample size was in this published study, how the sample size was determined, and whether randomization was utilized. So, and during this, it might be helpful to consider how easy was it to find this information, and maybe what changes could help you to find this information better. So I'll just move us across. So these are what the ARRIVE guidelines say about sample size, what information we consider to be important in these areas. So for sample size, we ask researchers to specify the number of experimental units in each group. And we ask researchers to explain how the sample size was decided, including giving details of a sample size calculation if done. For randomization, we ask the researchers to state whether randomization was used, and if so, provide the method used to generate the randomization sequence. Now, what I'm going to do now is, I have hidden this board, but I'll open it up. Here we have an excerpt from a single study, McQuaid et al. I would not like you to read the whole paper. We, of course, don't have time for that. But we have an excerpt from the methods, and we have one of the figures. What I would like you to do is I will just bring you over to this second board. What I'd like you to do is have a little look at the information here, have a little read through for a few minutes, and then basically see whether or not you can find the information we're looking for. And when you have done that, I'd like you to basically see if we can answer these questions quickly and easily. The easiest way to do that is to just, we have some post-it notes hanging around here. You can just grab one of these, pop it where you want it, double click on it, and put whatever answer you have. So for example, if you found the sample size to be 67, we could just write n equals 7. So we have 2 of these, but I think it might be easiest to just do a single one for now and see how we get on with this. So I thought maybe we could have 5, 6, 7 minutes to take a look through this information, see whether or not you find it straightforward to find the information you need, and whether you can put the information down over here on this answers frame. I am very happy to explain this further as we go along, so please feel free to ask me any questions if you're having difficulties with this. Otherwise, yeah, hopefully enjoy. And at the same time, I'll take a quick look at the chat. So Krista has asked, you'd love to organise a fun or hands-on workshop for researchers on randomisation and blinding. That is definitely something we can do. Randomisation, we actually, in pre-pandemic times, ran a randomisation and blinding workshop for researchers at the NC3Rs. We run that at universities, and it's something we can. I can definitely put you in touch with someone at the NC3Rs who would be interested in doing that. If you would like to drop me an email afterwards, then we can yeah, we can sort that out. what I would also highlight is perhaps the question on here is, what, if any, evidence is there? It's perfectly valid. It may be perfectly the case that there isn't any evidence in these papers. But I guess what this exercise is really to highlight is how this information is presented, whether or not it's easy to find this information if you're, for example, looking at a large number of papers and you're trying to either reproduce them or you're trying to understand how reliable the information is. Yeah, just getting a hold on kind of the ease or difficulty of that and how we might improve it. If anyone is following along, I will just zoom in here if you want to be able to read. So we'll just have a couple more minutes just to avoid us sitting in silence for very much longer, and then we'll come back. See how we're doing. Okay, it seems like everybody has stopped filling in the post-it notes now, so I'll come back to you now. So it seems like everybody is just about correct. So in terms of the sample size, we had N7 or 8 per group, 14 or 15 in total. The sample size does not seem to be justified. There's no description of how it was chosen. and there's no proper description of any randomization that took place. And what this really is to emphasize is the kind of time that it takes to do this. And I would not say this is atypical of research papers that you find. It takes you, particularly trying to look through several different papers to design your experiment, to look at what other groups have done. It can take you an awful long time to kind of read through the information, to try and get this basic bit of information. And you get to the end of it and find that the information is missing and it's absent, and you don't know how well you can trust this these results as a result of that. And there are you've had kind of difficulties in finding the information that you need. I should say that the second paper we were going to look at did contain a bit more information about this stuff, so it wasn't just going to be one paper with nothing in it. But as I say, for the reasons of time, I think it's best that we just leave the demonstration at one paper for now. Did anybody have anything that they thought might improve the way that these details were reported, or could you think of any strategies that might help your own research reporting kind of more clearly? If not, then I can talk about a couple.
Well, maybe I can say something.
Sure.
I think they really wrote it in a narrative kind of way. I think if you have it more structured or like point-wise or something, it's easier to find what you're looking for, or maybe like make it fat or bold or underlined, something like that.
Yeah, but I as I say, I wouldn't say that this is a dissimilar style, an uncommon style that you'd find in research papers. And when you've got, I think a lot of researchers, when they do systematic reviews, find that they have to read a lot of papers. They're trying to analyze the quality of the papers so they can get an idea of what's good practice and what isn't. And they can find this very frustrating. The reporting is very difficult. It's been sort of very poorly done. So we've had a couple in the chat as well with the graphic. That's an excellent idea that we will something that I'll discuss a little bit more in a few minutes. And yeah, supplementary material directly addressing the guidelines point by point, again, is a very useful idea. Okay, so now I'm going to go back to this presentation. I'm going to talk to you a little bit about resources that using Arrive and the NC3RS provides that might be able to help you use Arrive and to report better in general. So to support researchers in using the guidelines, we've developed a pretty broad range of resources. So the first of these, as I mentioned a couple of times and just mentioned in response to a question, is our explanation and elaboration. So all of the information in this explanation and elaboration publication is now on our website, which is arriveguidelines.org. Oh, excuse me. Sorry. Apologies. There we go. Arriveguidelines.org. As I said, this information explains the background and the rationale for each guideline item. It provides examples of good reporting from the published literature, and it's set out hopefully in this quite easy to navigate fashion. So each item has its own page, each sub-item has kind of its own tab, and there are tabs for the explanation of the item, examples of how to report well for that item. And soon, hopefully sooner than seems to be happening, we'll have the facility for users to be able to submit their own examples, users and organizations to submit their own examples of good reporting, which might help, which will help bulk up our kind of numbers of examples in particular fields. So in addition to this, we have a few other resources that I'm going to now talk to you about. We have a webinar, which is longer even than this talk and goes into a great amount of detail about the importance of other items and the guidelines, why they should be reported. That's available again at our website. We have fillable checklists for the Arrive Essential 10 and for the full Arrive guidelines, which I'll talk about a little more in a minute. We have an operationalized questionnaire. This is designed for journals to quickly and easily assess compliance with the guidelines. And we have so far 6 translations of Arrive 2.0, with another 2 very shortly to be published, which again are available on the website. I'm now going to have another break from the presentation to show you a few of these resources just and how they work in detail. So this I mentioned just a second ago is an example of an ARRIVE guidelines or the checklist. This is something that we make freely available on the website, and it's also requested by quite a few journals now. An increasing number of journals will request that you submit an ARRIVE guidelines checklist alongside any manuscript describing animal research. So what this is a fairly simple, easy to use PDF that gives you the details of the guidelines and gives you fillable boxes down the right here that you can, in which we ask that you put in details of where you can find the information relating to each item. So I've just put in a few kind of examples of the kind of things that might get written in here. So you can say that the information is within the methods section, supplementary methods. You can provide details of the line numbers that it's on, the pages, figure legends, paragraphs, and you can also use this section to provide reasons why the guideline item has not been reported. If there are many valid reasons why you might not report particular items in a study. The one I've given here is it's not possible to blind your two groups of mice because there's an obvious visible difference between them, for example. So yeah, this can be, we have versions of this for just the essential 10 and for the full ARRIVE guidelines, which will depend somewhat on what journals require. This can also be useful during the course of your study as well, and during the writing of your manuscript, as it allows you to kind of keep track of whether or not you've included the information that you should be including in your manuscript. Next, I want to talk briefly about something we've recently released. This is our Essential 10 Compliance Questionnaire. This is designed for journals in the main part, for them to be able to evaluate in a fairly quick and streamlined fashion how well a manuscript complies with the ARRIVE Essential 10. It can be applied to any manuscript that describes animal experiments. And the way it works is we have taken the guideline items and we have operationalized them into questions that can, in most cases, be answered in a binary fashion. For example, which allows journals that that at the moment don't do any checking of the ARRIVE guidelines to check it in quite an easy and straightforward fashion. So, for example, the first item, are all experimental and control groups clearly identified? Yes, in at least one experiment, or no. And the same applies to almost all of these questions. For example, again, randomization, is the method by which experimental units were allocated to groups described? Yes or no? And as I say, this is designed primarily for journals to kind of simplify their workflows. However, it can also be very useful for looking at your own manuscripts. And it's hopefully something that's quick and easy for you to go through and see whether or not a journal would consider your manuscript to be compliant with the guidelines. And lastly, I'd like to show you, although everybody here, it's greatly appreciated how well everybody speaks English, we have produced a number of translations of the guidelines, including a Dutch translation, which I thought might be good. This was done in collaboration with a couple of the people you've heard from already today. So Monique and Ivo Tibosh worked on this translation along with another couple of people. This has hopefully a fairly comprehensive introduction to ARRIVE, how to use the guidelines, and where further information can be found, along with all of the guideline items themselves get translated into Dutch. So you can find that on our website as well, and that will hopefully make this a little easier. So I will just pop back to my chat now. Apologies, I've just done this one. Lastly, very quickly, I'd just like to go through some of the other resources that the NC3Rs has available. The NC3Rs on our website, we have what's called the Experimental Design Hub. This is just about to be redesigned, so it won't look like this for very much longer, which has a whole range of other resources to help researchers understand and implement good experimental design. It covers topics like systematic reviews, pilot studies, power calculation, and statistics. But what I'd just like to quickly highlight our tool, another tool we have available, which is called the Experimental Design Assistant. This is a free online tool that's there to help researchers design in vivo experiments more rigorously. It was developed by experts in experimental design, statistics, and specialized IT systems. It has nearly 11,000 registered users. And what it does is, somebody just mentioned a few minutes ago, it allows you to graphically represent your experimental plan. And it kind of functions as a personal statistics assistant. So the program uses computer-based logical reasoning to provide bespoke advice and feedback on your experimental plans. It gives you recommendations on statistical tests that are appropriate for your experimental design. It helps you determine the most appropriate sample size, doing power calculations. It provides dedicated support for randomization and blinding, and it will produce a summary report that summarizes the key information in an experimental design, which can be useful. As I mentioned, this is an example of what an EDA diagram looks like, which is kind of how you can kind of build your experimental design in the EDA like this, and then actually use this picture to represent your experimental design in a publication should you want it. We're actually about to release a version of the EDA that has the capacity to kind of export these in more useful formats for journals. So as I say, this is what an EDA diagram looks like. You build your experiment using these different shapes, which are called nodes, which denote each different stage of the experiment, and the arrows link these together, showing how they relate to each other. This is a fairly simple example that shows an experiment involving measuring blood glucose, but diagrams can be very much more complicated than this and can accommodate really any study design you can come up with. We have experimental templates on the EDA website, which we're hoping to expand in the future. Each of the kind of individual nodes contains detailed information about each step and the kind of parameters of the experiment. And it's really just a really useful way to help design your animal experiments in a robust and reliable fashion. The EDA is also useful when you're doing your reporting, which is of course the topic of this discussion. So although experimental design and reporting are superficially kind of two different parts of the animal research process, their focuses are linked together, and there's really a good degree of overlap between the resources that are designed to address each one. The ARRIVE guidelines give extensive recommendations on good experimental design, and using the EDA is really an ideal way to fulfill many of the recommendations laid out by ARRIVE. You can use an EDA diagram to quite easily describe a study design, sample sizes, experimental procedures, outcomes, statistical methods, among other things. It's a great way to report those things. So that's all from me today. I'll of course be very happy to answer any questions you've got, or if you'd like to get in touch with me or anybody else at the NC3Ls, my email address is there. We've got our NC3Ls website, the ARRIVE guidelines website, and so on. So thank you very much.